is 100. 20 randomly selected statistics students took an IQ test, and the mean of their score was 112. Which of the following statements is/are true? So parameter I looked up. I can't remember what it was. Let me look it up again.
Let's see. It's a true but usually no number that describes the population. And then the statistic is an estimate of the parameter obtained from a sample. So I think the statistic is 112 and the parameter is 100. Well, actually, what do you think?
Well, you said statistic was what again?
The statistic is the estimate of a parameter obtained from a sample, is what I have written down in my notes.
Yeah, because I looked online, it said a parameter is a characteristic used to describe a population. So that would probably be the 100 because that describes the population score.
So 100 is the parameter and 112 is the statistic.
Yeah, because I think because you said statistic is just part of the sample.
Yeah, I think so. So that's what I put in my notes.
Yeah, that makes sense to me.
Okay.
So Rotham City has four distinct neighborhoods. The property value are very similar with each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property value and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' response to the proposed increase in property tax? That was a mouthful. Hold on.
Yeah.
Let me look up.
I think, well, if this one's the same as yesterday, I'm pretty sure it is. I said stratified random sample because they take the samples with things that are similar, and it says each neighborhood has property values that are similar. But let's look it up.
You know what under what chapter it is?
I don't remember. I can look at the review because it tells you. 1 second.
Oh, okay. Sorry, I'm just trying to look it up in all the stuff.
I think it's.
Okay, I found it. Sorry.
Oh, did you? What chapter is it?
It is
2?
week 2. Yeah.
Oh, okay, sounds good.
So it says. What did you say it was? What did you say?
Stratified random sample because, let's see, a stratified random sample works well with the items that are similar within each stratum and tend to differ from one stratum to another. A certain number of items is randomly selected from each of the strata. So I said that one because the property values are similar within the neighborhoods, and then the samples are selected out of each of those neighborhoods.
Okay. Yeah, I mean, that makes sense to me. I'm trying to find, I lost it. I had it, but.
Oh, it's okay.
Where did it go? I don't know where it went. So, yeah, I'm fine with that.
Okay.
It wouldn't be a simple random because it's in certain neighborhoods, right?
Yeah, they kind of categorized it. They didn't just do something, just randomly.
And then systematic is just a system.
Yeah, I think that's every case, every fourth one.
Cluster. What's a cluster sample?
Those are the groups, you.
Oh, okay. I see.
Select samples from a cluster, I guess.
Yeah, that makes sense to me.
Okay.
Okay. When designed experiments are conducted in the public school systems, researchers typically choose a particular district and randomly select teachers of say, fourth grade students in that district. The experiment is then conducted using all students in the selected class. What type of sampling is this?
So for this one, I said cluster sample because they're taking fourth grade students and then they conduct using all the students in the selected classes. So like,
And it wouldn't be systematic, right?
I don't think so because it doesn't say like every
Like,
fifth student they will take.
okay,
Not systematic, I'm pretty sure.
okay, yeah, that makes sense. I really hope we're getting this right.
Me too.
um, 7. At a school fundraiser, the name of every person who attended was entered into the drawing. At the end of the evening, 6 names were selected to receive door prizes. Isn't that simple? Random?
Yeah, I think it is.
Because it's just like,
Yeah,
so,
just randomly selecting 6 names, so yeah. And it's a drawing, so that's usually simple random.
so a special interest group is conducting a survey regarding wolves in Yellowstone National Park to adequately gauge opinions on both sides of the political spectrum. The researchers took a list of registered Democrats and selected a simple random of 100 people. Then they took a list of Republicans and did a simple random. Which type of sampling scheme was implemented?
So I said cluster just because they formed 2 different groups like Democrats and then Republicans. But I mean, it could be, I don't know, stratified also just because like within those groups they're pretty similar. But I don't know. What do you think?
Um, I think it'd be clustered too.
Yeah. Okay. Hang on, I'm just reading the definition for it. It says cluster sampling. Take all items in one or more randomly selected clusters. Oh, so they're randomly selected clusters. And these aren't random. So I wonder if it's stratified just because that's when they're similar to each other. I don't know.
So have we been doing that wrong then?
Which part of it?
Because we selected cluster for 6.
Yeah.
So would that just be stratified then?
Well, now I'm confused. So, yeah, I'm confused what the difference is between cluster and stratified.
I'm looking up an example of cluster.
Okay, perfect. Because cluster, it says that it's randomly in take all items in one or more randomly selected clusters. So the clusters are random. But Democrats and Republicans, I don't think that's random.
Yeah, they're pretty close.
Are they? Dang it.
Yeah.
So what do you, okay, for that one, I kind of want to say stratified just because, like, Republicans and Democrats, that wasn't something, I don't know. It doesn't seem very, like, much like a random cluster to me.
So would we say 6 is cluster and then 8 is stratified?
Maybe. What was 6 again? Let me read it. Yeah, I think that's the cluster. That's confusing between those two though.
Yeah. But it makes
So
sense as cluster.
okay. So we'll put that 6 as cluster, and you want to put 8 as stratified.
Yeah, we'll do that.
Okay. Hopefully somebody comes in to check with us.
I don't know, so it might just be us.
It might be. They probably already took their exam.
Yeah. Okay, so for 9, open the data file, crosswords purchase. Where's that at?
Oh, that's on the individual preparation. Like there's a thing to click on, and you just go through there. And then you use SPSS. I still have that up. That's not it. Okay, so analyze.
I don't see it on the review for exam. Is it under the review for exam 1?
Is it under what?
Is it under? Oh, found it. Okay.
Did you? Okay, good.
Okay, got it. So many like different files. I have to keep track of them.
I know, me too. It's rough.
Okay, so got that.
Okay, so what's it asking for again? Let's see. Using software, calculate the mean of these data. Okay, so I have it on SPSS, and I got the mean as 4.7711. So 3 decimal places. Let me know when you get it.
I don't have that that system you bought.
Oh, you don't? Are you going to buy it before the exam?
No, I know there's a different way you can do it so you don't have to buy it.
Oh.
I don't remember what it was.
Oh, I know what you're talking about. I tried it, but I couldn't figure it out.
I should probably figure that out before tomorrow.
Yeah, because I don't know if you watched his video that he put out today, but he said that if you don't have that, there's a file that you have to open, and you can only open if you have it on the exam, so that you're going to use on the exam.
Okay, so I need to do that before.
Yeah, before you take it.
Can we just go off of what you got for that? That's okay.
Yeah, I just hope it's right. Are you using Excel though?
I have Excel, but I don't know how to find the mean.
Okay.
So I just highlight it all and then push the mean.
I don't know Excel.
So it's
So
just
I'm
the
not
mean
sure.
of all of them, right?
Yeah, it's just the mean of all of them.
I might be able to figure this out.
Okay.
Because the question said is to find all of them, right?
Yeah. Says
Oh, yeah, I got it. So the 4.771.
perfect.
Wait.
And can you find the standard deviation with that? Or
I don't know.
it's okay. I'm just wondering. I can tell you what I got.
Okay.
I got 1.912.
I'm just going to see if I can go fast.
Okay.
I probably can, but I'll just do it later.
Okay. Sounds good.
So you said you got 1 point.
912.
Okay. And
And
then, sorry. And where's
oh,
proof for the histogram?
yeah, I did that. It's part of the review.
Okay, yeah, because
Yeah, it's on SPSS, and if you just like graph it, and then you just click create a histogram, and it pops up.
okay. So 12. Okay, so what is the value of the number that goes in the position marked with an A in the table? So
Oh, there it is. I was like, where is this at? Okay.
Jessica Mayer and her research team measured the body temperatures of a sampling of diving elephant seals. A thermistor was placed at a specific location on each seal so that to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated that the typical body temperature of each seal. Okay, whatever. That's just words.
Yeah, I think that's nothing.
Okay, so the seals, and then we need to find the deviation for the mean.
Yep.
So to find the mean, we just have to do for its bottle. So what's the number? Like, what's like the standard number for it? Like, what's x? Oh, x is 37.91. But then what's the x over?
The mean, like, so you have to add those up and divide them by 4.
Oh, okay.
Yeah, so you just find the regular mean there.
And then just subtract it.
Yeah.
Okay, that's easy.
Mm-hmm.
So for the mean, I got 38.075.
38 point. Okay, I think I got 38.0725. Let me do that again really quick.
Okay.
Because, huh. 1 second. I was trying to plug it into SPSS to get quick results. To see if I could do it. So I gotta do it by hand real quick. Yeah, I got 38.075. Is that what you said you got?
Yeah. So then
Perfect.
subtract that from 37.91.
Yeah. So
But 37.91 is the first number we subtract.
No, the 30. Yes, it is.
Mm-hmm. So then negative 0.165.
Yes.
And can it be negative, right? Standard deviation can.
Just says what is the value of it. Wait, we're looking at the mean. Like you're looking at the standard deviation from the mean. And when you plug it into that chart, it can be negative.
Oh, so we're not finding the standard deviation, right? We're just finding the...
Yeah, well, it's the deviation from the mean, but like in the next, like with B, we're going to square that deviation.
Oh, okay.
So it'll be positive. So I'm pretty sure it doesn't matter that it's a negative, because I thought in the previous charts like this, they had negatives listed. I have one written down that I got out of the book, I think. So negative 0.165, right?
It says, I looked it up, it says standard deviation can never be negative.
But it's just the deviation from the
Oh,
mean.
okay, then sorry, my bad.
I don't know. Maybe it can't be.
I just don't want to get it wrong.
Dang it. Do you know where a chart is? I found it once, but I can't find it again. I looked for it earlier. Because I think you're just saying what the difference is, so we probably could just make it a positive. Do you want to do that?
Oh, I'm just trying to see, look at the notes.
Okay.
I'm not finding anything.
Huh. I don't. Oh, let's see.
So it can't be negative. So the deviation from the mean.
We can. Let's see. Yeah, it just says deviation from the mean. I thought I saw a chart like that. Just don't even know where to look because I was looking for it before we had this, but let's see. Do you know what lesson this is?
Lesson 3.
3? Okay. I'm gonna try to look it up really quick in lesson 3. Because there should be a chart. Because I copied a chart from somewhere.
Mm-hmm. Oh yeah, it is. Okay, I see the chart. Yeah, it can be negative.
You found it?
Yeah.
Where's it? Where did you find it?
It is under. It's past the mass. It's like
Okay.
towards the bottom part. Just keep scrolling and you'll see it.
Okay, I'm just going away.
Sorry, that's not very like good.
Let's see. I am not seeing it under the box plus. Oh wait, no, there it is. Yeah, so it's -7. Yeah.
Okay, so that's good. Then for B, for 13, so it's negative 0.165.
Yeah, for 12.
Okay, so 13. So let's find B. So 37. So the deviation for the mean is negative 8.25. And then I think we just square that.
Well, yep, you square that.
So then 681.681.
Oh. What did you get?
0.681.
Yes, that's what I got too.
Cool. That's positive. That's not negative.
Yeah, that's positive because you square it.
So 14, what quantity is equal to the sum of numbers in the squared deviations column?
So on this one, I was thinking the variance because S squared is variance and the standard deviation squared, I think, is what S squared is. But yeah, I don't know.
I'm just trying to see. I think so. I don't know.
Okay, that's a guess. Yeah, because I'm really not sure. Um, yeah, I'm pretty sure that's what it said. Like S squared is the mean and S squared is the standard deviation squared. Because there's an S squared and then there's like the sigma squared, and those are both the standard deviation squared. I'm pretty sure. It's either that or none of the above.
Cool. I'm just trying to I'm like Control F. I'm just trying to search for.
Oh, you're good. But actually, on my chart here, I have like, I don't know where I got it from, but I wrote down a bunch of numbers. I copied a chart and I said sum equals like some number, and the variance is a different number. So I think it's none of the above, actually, the sum of it.
Yeah, because I can't find anything.
So it's probably none of the above. Let's see. I'm gonna try to. I'm gonna try to plug this into the program and see what it gives me. So 37.91, 37.25, 38.98, and 38.16. Okay. Analyze.
Yeah, I don't really know.
Okay. I mean, what?
I would say none of the above, I guess.
Okay. Let's do it then.
What is the standard deviation of these temperatures?
Okay, so I just plugged it into SPSS and I got 0.715 for the standard deviation.
715.715.
Yeah, that's what I got.
Okay. Under certain conditions, the standard deviation can be negative. That's false.
False?
Yeah, because it can't be negative.
Okay. Man, I really hope this is right. Like all of this.
Me too. Okay, so okay, so they did the same exact thing. Which location resulted in the most consistent temperature measurements from one seal to another? Because they just placed them in different areas.
Yeah. So on this one, I gotta find it. I said extradural. Let me check that though. 37.
Standard deviations is the closest.
I think because the means are the closest. Is the standard deviation closest? Yeah, that would work too.
Did you say what did you say? The extradural?
Yeah, the extradural.
It's not. It would be the hepatic sinus.
The hepatic sinus? Okay. Oh, wait, why would it be hepatic sinus?
Because it was because the mean that we got from above was 38.075, And the mean
Yeah.
for the hepatic sinus is 38.070.
Yeah. So do we do it off of the deviation or the mean?
With the most consistent temperatures.
Yeah. I don't. Dang.
Yeah.
Well.
No, I don't think it would be that.
They don't have the same names. I thought they had the same names. I was just looking at the columns. So I don't even get what they're asking.
So it's just asking, like, the temperatures, and they moved them different places, what would be the most consistent?
Okay.
So if they did, let's see, I think smaller the mean, the better it is.
Okay.
Because if you look up at the original, and let's just say all of them were 37, that means the mean would be 37, and they'd be more consistent anyway.
Yeah.
So I think you're right about the
Extradural.
Yeah.
Okay, we can try that.
The standard deviation is just the difference in between, right?
Yeah, it's like how far away it is from the mean.
Yeah.
So this one's closer to the mean, but they do only have 3 samples. But I mean, the other ones don't have much more, just 2 or 3 more. So.
Well, because I mean, you could have for like the arterial, you could have like, let's say 40, 36, just all over the place. You can have really high ones and you can have really low. Like you could have 3 high and 3 low, and it could still be 38 in the middle. But the most consistent temperatures. So you would say, and the extradural is only 3. And if the average is 37, it can be like 37, 38, and 36. So it's pretty consistent, I feel like.
Yeah.
Okay, so
18 true.
so 20, so I mean 19, what is the third quartile?
8, right?
Oh, shoot. I think so.
Yeah, I'm pretty sure it's 8. According to my notes, it's 8.
Is it just the third quartile?
It's the right end of the box.
Yeah.
And the first quartile is the left end where the box starts.
Sounds good.
Okay.
What percentage of the data aligns between 4 to 8 hours? 50%?
Yeah. That's what I got.
Okay, hold on a second, sorry.
21.
Okay, so an observation from a normally distributed population is considered unusual if it has more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentration of above 10 ppm parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration is between 1.59 and 2.52, and values outside this range are unusual. We will assume that the 1.59 is the value of mu minus 2 times deviation or whatever, and then mu plus 2 deviation is equal to 2.52. Estimate the mean of the measured nitrate concentrate in Rexburg's drinking water.
Okay. So.
I have no clue.
Great. Okay. Well, it says that it can't be more than 2 deviations away. Oh boy. So I think both the okay.
I don't even know, honestly.
This is a crazy question.
Because the least, so the least would be 1.49, and
1.59, yeah.
the greatest would be 2.52. So would you just add those up and divide it?
That's the best guess I've got. So I got 2.055. Oh, that's such a weird question.
I guess that's what it would be, because I mean, it's talking about 2 standard deviations, but that has nothing to. Does that have anything to do with the mean?
Well, if you do the mean minus 2 standard deviations and the mean plus 2 standard deviations, like I think the means equal each other. So if you put an equal sign between those, then like the 2 standard deviation gets cut out. It cancels out. So
because if you were to do like 2.055 times 2, it would be way over the max.
would it? Okay.
So like, never mind. Just ignore what I was saying. I just say that's what it is. I really don't know.
Yeah, me neither.
So 2.055.
Okay, sounds good.
Okay, so then the 22 says estimate the standard deviation
Okay, so
of the measured nitrate content.
okay, so if we have, it can't. Let's see. So the mean minus 2 standard deviations equals 1.59. So we could
What was the standard deviation? Oh, are you saying so the standard deviation is like 2.055 minus 1.59? Like that's the deviation, right?
No, that's not what I said, but yeah, that's probably a deviation.
What did you say?
Oh, I was thinking about solving the equation 1.59 equals mean minus 2 standard deviation. And just to solve for the standard deviation. But, I mean, we can see if we come up with the same answers.
You lost me on that one, so I mean, whatever.
Okay. Okay, so, like, there's an equation here. Look at it has, like, the mean plus 2 sigma, so standard deviation, is equals 2.52. And then you just solve for that sigma because we found the mean.
Okay, you do it your way and then tell me what you got, because I think I got an answer.
All right, what'd you get for an answer?
I got 0.2325.
I did too. Awesome.
Okay, yeah, because what I just did, I just subtracted the mean from the lowest and then divided by 2.
Perfect.
Wait, I'm glad we got that right.
Me too. 0.23. It's going to be 3, right?
Yeah.
0.233.
So between what 2 measured nitrates do approximately 68%. So it's going to be 1.82 plus 2.28.
And 2.288.
Yeah.
Right? 1.822 and 2.8288.
Yep.
Okay, awesome.
What is the value of the mean of standard normal? What is the value of the mean of standard normal?
Okay, wait, what is the value of the mean? Oh, what? What's it asking for here? Just the mean again?
The standard normal. Standard, okay, what would the standard normal distribution be? Wouldn't it just be 2.055?
Yeah, well, that's what I thought, because it hasn't, yeah, it's
It
not.
hasn't given us anything else, and it normally would say in a thing, like it would say, oh, well, the mean of this is.
Yeah,
But
unless we have to take, like, the lowest value, and no.
No, I think it's 2.0.
Yeah, I think so, too. So what is the value of the standard deviation of a standard normal distribution? So that would be the same, too, wouldn't it?
It would be 0.233.
Okay, so that's the same.
Right?
Yeah, that's what I got.
Okay. I really hope
Cross our fingers.
right. If not, we should email him and be like, hey, it was just the two of us. Can we get some help?
We were very confused on the questions. Yeah, that'd be good, especially before we take the exam tomorrow.
To figure it out. Okay, so the admissions committee for most masters. Okay, so it's been shown that the scores of the GMAT are normally just distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum for the GMAT is 500, but is rare. But it is rare for students with scores less than 600 to be admitted. What is the probability that a randomly selected student would score above a 542.3?
Okay, so this one I was confused on because it says with a 542.3. Like when we use our normal equation, we usually have like a different mean, like 500 minus 542.3 divided by, what's it?
Oh,
20.54 divided by the square root of n.
yeah.
You know what I mean?
Yeah.
So on this one, what I did is I did plug in 500 minus that, and then I got my z-score, and I plugged that in, and I did everything above that. But that's for like that's the probability of scoring above 500, not 542.3, I think. So I don't know how to get that. I don't know what equation to use.
It wouldn't be I don't think it would be where you do the box not the box plot, but the 68, 99, and 95 and 90 whatever.
Did you say you think it is or you don't?
I don't know. That's what I was thinking originally when I read this question.
Were you? Okay.
But
So
I don't think that's it.
Well, if we did that, it would be
because it was 542 the mean. So and I don't think it is that.
Okay.
Because it would give us a range. Okay, it'd be like, well, I don't know.
So, well, what we could do is probably use that equation, the standard deviation divided by the square root of n, to get our z-score.
Yeah.
That's how you get z-score, right? So if we did,
yeah.
But that would just be 120.54 divided by 1. So that doesn't make sense either. Never mind. I can do the next one. I just can't do that one.
I don't know, because like I did the standard deviation. I think you're right about what you're saying. Plug in the z-score.
Yeah.
And do that way. Because I don't think the 68, 95 and the other percentage thing would work on this.
I don't know how the z-score would work, though. I don't know how to get the z-score with just the 542.3.
Well, would it just be 50%? I don't know.
Well, it's the mean, but it doesn't have another mean. Like, I don't know.
So wouldn't it just be I don't really know. So would it just be 500 minus 542 divided by 120.54?
That's what I did, and I got 0.637. But
let's just say that.
Okay.
0.6 because it says round to 10.
Will you check me on that math?
So you did 150 minus, oh wait, not 150.
No, 500.
500 minus 542.3, 120.54. And then you got, for the z-score, you got 0.35.
That's what it should be. Yes, that's what I got for the z-score.
Okay.
And then you plug the z-score into the applet.
And then you just say whatever higher than
negative 0.35.
Yeah. That makes sense to me. So 0.6, whatever. Just move on.
Well, hang on, I just gotta. Yeah, 0.637. Oh, so it would be 0.6. Yeah, you're right.
Okay, so what is the probability that a randomly selected student will score above a 600? So then 500 minus 600?
600 minus 542.3.
2.3, for the z-score, I got 0.4786.
Yeah, I got 0.479 about.
Okay, so do you want to plug that in real fast and tell me what you got?
I got 0.684.
So 0.684.
Yeah.
Okay. So
Is that a negative zero? No, that's not negative. Oh, it's less than.
oh
Yeah, so 0.684.
yeah.
Yeah.
Okay. So what is the probability that a randomly selected student will score above? So just what's that?
1 minus that.
Or
So
don't you
what?
change it over on the applet? You don't like do 1 minus?
Yeah, but you can, either way works. You can do 1
Is it the
minus
same?
that, we'll get the same answer. Yeah. I got 0.316.
Okay. 316. Find the GMAT of that corresponds to 10th percentile. Okay, this stuff I'm not good at.
Oh no.
All these quartile ones, I have no clue.
Okay. Okay, so it says the 10th percentile. Does that mean like 10% or is that like a different percentage?
I have no clue.
Because I need to know that, because if it's percent, I can solve for it, but if it's not percent, then I don't know what that is.
Let me see.
Because I mean,
Sorry, go
yeah.
ahead.
No, go ahead.
Um, because he sent out a video saying, "Oh, that's for week 3, and we're on lesson 8." Never mind. I thought he was gonna post something about the quizzes, the problems that we missed, but he hasn't posted anything about it. So never mind. Yeah, I haven't.
Because pretty sure it's percent. Because if you say like the 75th percentile, that's like the third quartile, which is like 75% of the way to complete. And there's 4 quartiles.
Okay.
So I'm going to treat it like a percentage right now. And so what I did is I plugged 0.10. What, just what?
It says, yeah, round to the wholest number.
Okay, so I put 0.10 into the applet, and then what's it asking for? How many will what?
And the 10 percentile.
Okay, so then I got a z-score of 1.282, but it's going to be negative 1.282 because I think it's, or is it?
I'm just like looking at all the homework.
Okay.
Okay, I found on how it says to calculate it.
Negative 1, 2, 3.
Okay, so let's see what it did. Okay,
Okay.
so it said to solve for I can't remember what x is again. So what they did to find the 90th percent is so they did the z-score equals x minus u. I can't remember what that was.
Yeah, the mean.
The mean, so over the mean over the standard deviation and solve for x.
Yeah, so that's what I just did.
Oh, okay.
And I got my z-score as negative 1.282 because I plugged 10% into the applet. And I got that z-score.
Well,
So
we're not solving for the z-score.
I know.
Oh, okay.
I used that z-score to solve for x.
Oh, okay. I get what you're saying. So you did that with the applet, and then you got the z-score, and then
Yeah.
okay. So then you got okay. So you did the z-score, and then what did you get for the answer?
I got 388.
Do you think that's pretty high?
No, because it says that their lowest, like they rarely go below 500. I think.
Oh, what's the score? Oh, the score. Oh, yeah. Then that makes sense.
Yeah.
388. So the 90th percentile. So plug that in for the applet. That's 90%.
That's just gonna be. It corresponds to the 90th percentile. Okay, hang on. Ooh.
We're almost done.
I know.
I'm
Oh,
kidding.
it's just positive 1.282.